Hello everyone, welcome back to Learn to Code in Python. So today is day 5 in our series. So we are trying to solve problems related to data structures and algorithms. So this is first week and we have solved problems related to arrays, and yesterday we did encounter two interesting problems. One was container with most water, and then one was valid palindrome. So today we have such similar interesting problems. So both of it is involving array rotation. So let's dive right into our problems today. So first of our two problems is rotate array. So rotate array problem is very simple and straightforward. Given an integer array of numbers, rotate the array to right by k steps, where k is a non-negative number. So for example, you have a number array like 1 2 3 4 5 6 7, and you have asked to rotate it 3 times. So how do we do it? There are multiple options. There are options where you can do this rotation in a 3 4 different type of ways. I've chosen a less simple and easier option, but which has some space complexity and time complexity, but we can have an optimized version than this as well. So to explain how I've solved this problem, I have created a simple visualization which will show you how basically this works. So this is our array and we are trying to sort it or rotate it 3 times. So what I'm going to do now is, in this we are going to have two separate queues. Actually it's marked as queues, but it can be list also. So what I'm going to do is, first loop, what I'm going to do is I'm going to go through this original array, and I'm just going to append it to either one of this queues based on n minus k. So if my overall array length is 7 minus 3, 4 elements, I'll append it into the front queue, and then 3 elements I'll append to the back queue, and then I'll clear the original array and populate this both front and back queue. So that is how I'm solving this problem in a neat and simple manner. And there is another option which you can do, is using reversal. First you can reverse the entire array, and then reverse the n minus k elements, and then reverse the k elements, and then reverse the n minus k elements. So that is another way to solve, where you don't use additional space, but within the original array you will just do this. But I was trying to keep my solution simple and straightforward. Even though there's a space complexity, I just want to solve this and I just want to submit and see if it works. So I think I have already submitted it, but let me just try one more time and see if it goes through fine. Okay, it looks fine. So this is my first problem. So let's move ahead for the next problem which we wanted to discuss today. This is again an interesting problem. So we have an rotated sorted array, meaning sorry about that. So we have an array which is rotated and it is already a sorted array. So I have an array of numbers 0 1 2 3 4 1 2 4 5 6 7, and rotated means you have rotated it 4 times, and again it's already sorted as per the number. So basically you'll it's already, the numbers are already sorted, and we just rotating it 4 times. Basically our array will look like 4 5 6 7 0 1 2. So in this, if you want to find the minimum on this rotated sorted array, how will you do this? So this is again very simple and straightforward. Again, you can use a symbol. You can use an easy logic to figure out how it works. And I'm using a 2-pointer technique. Basically, I have left and right pointers, and I'll be moving in. But again, you don't even need 2 pointers. All you need is a single pointer to see which direction you need to go to. So I have created a simple visualization for this. Let's just go and check this visualization for this before diving into the problem solution. So this is the array. So my array is 4 5 6 0 1 2 3. So in my loop, what I'm going to do is I'm checking this ith element with I plus 1 and I minus 1. So right now, when I'm checking this, whether it is greater than, I mean, if it is greater than this, then I will move and I mean, if it is if the I plus 1 element is greater than ith element, then I'll move left. If I minus 1 element is greater than the ith element, then I'll move right. So that's how I decide the direction in which I have to move. So first step, whenever first comparison, when it goes, it sees the left element is lower, so it goes to the left. And again, now since we have determined the direction, the second comparison is obsolete. That is the reason first comparison is again is it's going to go, even in the next steps it will be going to the backward direction. So now again it's 2 is lesser than 3, and then there's 1 which is already lesser than 2, so it's going to go and do the loop till it finds the minimum element. So right now we are just determining which direction we need to go, either left or right, and then we are moving the array accordingly to figure out the minimum element. So how I coded for this is, let's just go to the solution. So I'm initializing I is equal to 0 and n is equal to ln of numbers, and then I have exact logic what I've showed in the visualization. So if either one, I mean, if the number of I is less than the number of I minus 1, then basically I go in the left direction, or if it is greater than, then I go in the right direction. So at the end, this loop will break when the ith element is the smallest, then I minus 1 and I plus 1. So that's where we'll be returning nums of I. And again, let me just submit the solution and verify if it is working fine. I think I already submitted, but still, yes. So this is also accepted. So to wrap up today's two problems, today we had checked on the array rotation problems. In first problem, we had rotated the element by splitting it and then rearranging the subarrays based on k. And then the second problem, we found the minimum of a rotated array by using the pointers on the adjacent side to find out the smallest element. So these techniques are quite efficient and how easy to write, to remember during interview, and easy to code as well. So that's all for today. Thanks for joining. If you find this video helpful, please do like, share, and subscribe. And drop a comment if you have any questions or suggestions, and so on. Thank you.